Hey guys, all right, today we're going to talk about factoring our quadratics. Quadratic trinomials just means they have the x squared, the x to the first, and a constant in the form of ax squared plus bx plus c, but when that number in front of x squared, so previously we'd only seen it where there's a 1 and it just says x squared. Today we're going to figure out how do I deal with that if it's not 1. And or if when I check, like say in my first example here, there's no common factor that I could take out of all of them that would make a 1. So there's no common factor in this first example. I can't take or divide anything out of all three terms. So we're going to have to find a workaround here. Okay, so the first method we're going to talk about is called the guess and check method. Okay, to do guess and check, basically remember when we started with something that was x squared. We saw this in, say, the last video. If I had something like this, whoops, with my x in there, I'll fix it, with my x in there, that we knew it had to start off x and x. Because when we go to kind of FOIL or multiply these back together, x times x gave me an x squared term, right? It gave me that first term. It was always just x and x because we always just had one x squared in the beginning. Well, today that's a little different. We don't just have one x squared in the front, so now we need to think about what are some possibilities of things that could go in front of x. And so we have to think about what could I have that would multiply to 2x squared. Well, I think each of them is still going to have an x times x. But in this case, 2 doesn't have a lot of factors. It's a prime number, so it would just be 2 and 1. So I think this is our option. One of them has to have a 2x, the other has to have an x. Okay, they're each going to have an x no matter what here. And then our 1x, you can see I just got rid of, we can just think of as x. Okay, so we have an idea that it should be 2x and x, and I think that's the only possibility, which is nice. So now we look over here to this last term. And if you remember when we were multiplying things together, like say, for instance, here's a random example, x plus 4 times x minus 2, the very last step after you distributed the x twice and distributed your negative 4 was 4 times negative 2 gave us that constant at the end, negative 8. So we have an idea that the two numbers that we need to put in here need to multiply to positive 3. Okay, so the numbers we're looking for in there need to multiply to positive 3. So obviously 3 luckily doesn't have a lot of factors, right? It's just 1 and 3, another prime 1. So we only have 2 factors to kind of guess and check with. So does the 3 go here and the 1 go here? What are the signs I should put with them? And we can actually use some of the methods we used last time. If we looked at this last one, I can tell that my factors are going to be the same sign. It's either a positive times a positive or a negative times a negative. It's the only way to multiply and get a positive answer. So I know they're the same signs. And just like before, I can also look at the middle term to figure out which sign. So that positive 5 tells me they are going to be both plus. So now what I have to do with my 1 and my 3, the factors of 3, is figure out, does the 1 and the 3 go here, or does the 3 or the 1 go here? And I want to make sure that I'm going to get the correct middle term. So what we've guaranteed so far is the first 2 terms are going to multiply to get that. And by using 1 and 3, we're guaranteed to get the correct last term. Now we need to make sure we get the correct middle term. So where does the 3 go? Where does the 1 go? This is kind of the guessing and checking. So if I put the 1 here and 3 here, let's imagine foiling this back together. I'd get my 2x squared. 2x times 3 is 6x. 1 times x gets me a 1x. And 1 times 3 would be 3. And combining these, I get 2x squared plus 7x. Uh-oh. That is not the right middle term. So I got them wrong. Oh, man. So I got to go back and change them. All right, maybe the 3 goes with the 2x. 2x plus 3. Let's fix it. Okay, so the 3 goes here and the 1 goes here. Let's try that. And as you noticed, if I actually did this first step, that will always give me 2x squared. We've designed it to do that so far. And the very last step we did would always give me the 3. So quick way, if you think about the word FOIL, when you learned FOIL first, outer, inner, last, The quick way of checking to get the correct middle term is you can, oops, I didn't mean to erase the FOIL part. You can check the OI part, the outer and inner, to see if you have the correct middle term. So it's kind of a shortcut. Rather than doing all 4 steps, if you do the outermost 2 and the innermost 2, that gives me 2x and 3x. Sorry, that's making a triangle there. Which does give me 5x in the middle. That matches the middle. We know 3 times 1 gives me the 3 at the end. We know 2x times x gives me 2x squared. And that is our correct answer. As you can tell with this method, a little bit of drawbacks is there's a lot of guessing and checking. I mean, we found the right factors, but it took a while. Okay, let's try the second example. All right, to get to 4x squared, here's where I'm already running into a situation. It could be 4x and x, or because 4 has more than just 2 factors, it could also be 2 and 2. What if it was 2x and 2x? I don't know which case it is. Luckily for us, though, when I look over here, I know it's going to be opposite signs. So one's positive, one's negative. Oh, no. That actually gives us more options we have to guess and check through. One's positive and one's negative. I don't know. Does the positive go here and negative here or backwards? It's kind of a mess, right? There's going to be a lot of guessing and checking. Luckily, they only multiply to -1. The only factors of 1 are 1 and 1, right? That's a prime number. So I at least know the digits going in here would be 1 and 1 in either case. I just don't know where the positive and negative sign is, or if it's the top case or bottom case. What gives me the correct middle term? So you might have some intuition. I think if I put the negative here, when I do the outer, that gets me -4x. If I put the positive sign here, so they have opposite signs, right? That would give me +1x, which would give me -3x in the middle. I think that's actually the correct answer. So if I got rid of this, I think the top case is the correct version. But we might have had to cycle down to the bottom, try some cases out here. And what if that 4 was like a 12, and you had 1 and 12, 2 and 6, 3 and 4. There's 3 different cases to cycle through, like we had listed here. And then what if this number has a bunch of factors? This could take absolutely forever, right? Does not sound like a fun time. So there is another method. I know some higher level teachers aren't a big fan of it. It's called the bottoms up method, commonly referred to, that can help us get to these 2 answers a little faster. So I'm going to pause and erase some of this stuff, and then we're going to go through that with you. All right, here is my preferred method. There's nothing wrong with the other method other than it is a little more time consuming. It's a good mental practice for math, and you're more than welcome to do that way. That's how I learned when I was in school. This other method that's pretty new, I actually never learned this method until I was a teacher. It's commonly referred to as the bottoms up method. I guess like that song, right? Bottoms up, bottoms up. No, it actually does have to do with a bottom of a fraction coming up at one point in this process. So we can call this kind of like the advanced x factor as well. But here's what we do. We're going to turn it into one of these where a has a 1 in front. So we can factor it like before. But we kind of cheat mathematics here, which is why some teachers don't necessarily like this. But as long as we follow rules, we will always get the right answer. So let me show you how this will be a little bit faster. Here's what I want to do. I don't like that 2 in front. We're going to hide it by multiplying it by 3. So we're going to multiply it by the constant at the end. X squared plus 5x plus 6. 2 times 3 is 6. We're going to hide it over there with the constant, with multiplication. And now we're actually going to factor like we did before. So I'd be looking for 2 numbers that multiply to +6 that add up to 5, and I can start with an x and an x in my factor because we don't have that ugly 2 in front anymore. And the numbers that multiply to +6 and add up to +5 are 2 and 3. Okay, now this does not give me the original answer. So do not stop here. Not correct. Okay, this only gets me back to this step, and remember we kind of cheated some math here. So here's how we undo this. Imagine we multiplied this 2 over, right? To undo multiplication, what do? Well, you divide, of course. So instead of multiplying that 2 over, here's how we undo it. We're going to divide both of the numbers by 2. by whatever this a value is over here. Divide by that number. Okay, so we still have an extra rule, some rules to follow here. So we're going to end up with some fractions. And if they simplify to a whole number, like 2 over 2, write it as a whole number. If you have a fraction that doesn't reduce to a whole number, you have to try to reduce your fraction. Okay, that's important as well. 3/2 does not reduce though. Okay, and if you're left with a fraction, doesn't become a whole number, doesn't reduce further, here's where the name bottoms up comes from. We're going to bring the bottom of the fraction up in front of x. So that 2, I'm color coding here, is going to go in front of the x. And we're going to write this remaining factor as 2x plus 3. Okay, so if I lost you there, you might want to rewind and watch this example again. We're going to do the other one. But if you notice, it does match the previous answer. I wrote the previous answer down here when we did the guess and check method. The factors are in another order, but that doesn't matter which one's first, which one's second. We have the correct 2 factors. And for my money's worth, this way is much faster. So let's try number 4. Or sorry, not number 4, the other example, this guy. We're going to try it with the new method. The correct answer is down here. Let's see if we can match it. Okay, so first thing you do have to check for, though, when you do bottoms up is there a greatest common factor? You have to take those out first. And in this case, no, nothing in common. So we're ready to go. And again, we're doing this bottoms up because we don't like that 4 in front. So we're going to hide it by multiplying it over. Okay, so multiplying that over, 4 times -1 makes -4. Then we're going to x factor this out. To get to x squared, it would be x and x. And the 2 numbers that multiply to -4, but add up to -3 are -4 and +1. I guess I should go back and re-explain that as we've been talking about. This -4 tells me it has opposite signs. I apologize. So I know they're opposite signs. And looking at this, the bigger number is negative. So if I did my factors of 4, 1 and 4, 2 and 2, the bigger number is negative. I guess with the 2's, it doesn't matter which because they're the same. So I think the ones that add up to -3 are -4 and +1. But remember, this is a trap. Don't stop here. This is not the correct answer. This only gets us back to our cheated step, not the original. So here's where we need to undo our cheat. We multiplied by 4. Let's come back and divide by 4. Okay, just the numbers, not x, but divide by 4. Okay, our first one, we get a fraction, and it does not reduce. Doesn't give me a whole number either, so this is where we use the name bottoms up. We're going to bring that 4 up in front of x and get 4x plus 1. Hey, what do you know? It matches one of my factors down below. We're on a roll here. And over here, I do get a fraction that will reduce to 1, x minus 1. 4 divided by 4 is 1. So x minus 1. And there are our 2 factors. It matches what we have down below. All right, let's try a few more examples. And I think we're going to stick with that bottoms up method because it's kind of my favorite, man. Like, you can do this stuff really fast without having to do all that rough guess and checking. Okay, so factor completely. And our first one here wants me to 5x squared plus 8x minus 4. Okay, so first thing again, we check for before we use bottoms up. Is there a greatest common factor? No. 5, 8, and 4 don't share anything in common, and the last term doesn't have any x's. Okay, but we don't like this 5 here, so we know we're going to use bottoms up. We're going to hide that 5 by multiplying it over there. So that would give me x squared plus 8x minus 20. And we're going to factor this like we were working on last time. Okay, so I know it's going to start with x and x to get me to this x squared. Then we're going to use the negative 20. It's going to tell me my factors have opposite signs. One's plus, one's minus. And we need the factors of 20. I guess I could find a better place to put that. We'll do it down here maybe. The factors of 20 that subtract to 8. So the factors of 20 are 1 and 20, 2 and 10. 3 doesn't go in there. 4 does 5 times, and then 5 would be a repeat. So they're opposite signs, but the bigger number has to be positive to get me to positive 8. So the bigger number's positive, that means the smaller number's negative. And the ones that would add up to positive 8 for us are negative 2 and positive 10. Negative 2 and positive 10. But remember, this is a trap. Don't stop here. This only gets me back to our cheated function, not the original, or cheated expression. So to undo our cheat, we multiplied by 5 earlier. We need to divide by 5. Okay, so remember, if we get a fraction that reduces, boom, that reduces to positive 2, 10 divided by 5. We write it as our nice whole number. Beautiful. If we get a fraction that does not reduce to a whole number, reduce it as far as you can. Okay, 2/5 doesn't have any common factors, so I can't reduce. And here's where, again, where the name comes. We're going to take that 5 and bring the bottom up. That's a 5. I don't know what happened to my end of my 5 here. So it's going to be 5x minus 2. So we end up bringing that bottom up. Sometimes, by the way, you might end up bringing both bottoms up. Instead of just one, they might both not reduce to a whole number. That's very possible. You might also end up with a fraction that you need to reduce first, and that is important. So you could always check by foiling these back together. X times 5x is 5x squared. X times negative 2 is negative 2x. 2 times 5x is positive 10x. And 2 times negative 4, or sorry, 2 times negative 2 is negative 4. And I know I've got my numbers in the way there. This would give me 5x squared. The middle terms would give me positive 8x minus 20. Sorry, minus 4. Oh, goodness. And this is equivalent to the original, right? So that's a good check. Especially in the multiple choice test, you could always, multiply stuff together if you need to. But just to check that we had the right answer, and we do. Okay, let's move on to our second example over here. So again, really important. To use bottoms up, the first thing I have to check for, is there a greatest common factor? Yes, you have to take that out first before you try bottoms up. Okay, so yes, they're all divisible by 2. So let's factor out a 2 first. So dividing out that common factor of 2, we get 3x squared minus 8x plus 4. Okay, and in this case, the remaining quadratic in there, it does still have a number in front of x squared. So we're going to use bottoms up for what's inside the parentheses. So that's hard to factor unless we multiply that over. So let's do that. Hide that momentarily. 3 times 4 gives us 12. Okay. Now I need to find the factors of this kind of cheated step. Okay. Eventually, we don't want to forget about this 2 out here either, but we'll come back for him. Don't worry, 2. We'll be back. So I need 2 numbers that multiply to positive 12. That tells me they're the same signs. So either x plus or x minus. And in this case, the middle term tells me they are both minus. So the factors of 12 are 1 and 12, 2 and 6, 3 and 4. They're both negative, so I'm looking for the pair that would make negative 8 when I add them together, which is, of course, 2 and 6. So 2 and 6 in either order. But remember, this is a trap. We're not done yet. By the way, I'm also going to drop down my 2 here, so I don't forget about them. Don't you forget about me. There's a song like that, right? Okay, so let's divide each of these by the 3. Remember, I multiplied by that 3 over there. We got to come back and divide it out of those 2 factors. Okay, so I'm just keeping my 2 out here so I don't forget them. Here I get a fraction that does not reduce to a whole number. So bring the bottom up. We're going to have 3x minus 2. Over here, though, hey, that one does reduce to a nice whole number. Negative 6 divided by 3 is negative 2. And our factors for this are 2 times 3x minus 2 times x minus 2. So 3x minus 2 and then another x minus 2. And that's it. There's our factors. Okay, we're going to try one more example together, and then I'm going to give you some time to try this last example on the right. But let's see about this first one, because it is going to run into something different. So remember, again, first thing to check for, if we're using this bottoms-up method, is there a greatest common factor? And the answer is no. Okay, nothing I can divide out of all three of those. But again, I had this ugly 6 in front of my quadratic that's making this difficult to factor. So let's go ahead and multiply it or hide it by multiplying over there. So x squared minus x, 6 times negative 2 makes negative 12. Okay, now I need to factor like we were before. I need two numbers that multiply to negative 12. Or in fact, remember that negative 12 tells me they have opposite signs. So we need factors of 12 that multiply, 1 and 12, 2 and 6, 3 and 4. And in this case, the bigger number needs to be negative to add up to a negative number. So the bigger number is negative. So the pair we're looking for that would add up to a negative 1, you can imagine there's a 1 in front there that's hidden, is negative 4 and 3. Okay, so I'm just going to get rid of this so we have the room back, but negative 4 and positive 3. Okay, keep those in blue. But remember, this is a trap. Don't stop here. This only gets me back to this cheated step, not the original. So we need to divide away our 6 that we multiplied earlier. Okay, and the reason I wanted to do this one is when you check this first fraction, it doesn't give us a whole number, but we can reduce it. So if you divide the top and bottom each by 3, you get 1 over 2. Okay, for our second one over here, 4/6, if you divide the top and bottom each by 2, you get 2 over 3. Okay, so you have to reduce these fractions. Now that I have fractions, I notice that, hey, they didn't give me a whole numbers. They still have a bottom, and we're still going to bring the bottom up in front of x. So we're going to bring that 2 in the front. We're going to bring this 3 in front of this x. In this case, we need to bring the bottom up twice. We end up with 2x plus 1 and 3x minus 2. Okay, and this actually just saved us so much guessing and checking. Imagine what we originally talked about. To get to 6, it could have been 6x and 1x. It could have been 2x and 3x. In this case, we ended up finding it is the 2x and 3x case, right? But then we had to go through factors of 2. One's positive, one's negative. Where did they go to give me the correct middle term of negative 1x? And I think this bottom-up method saved us some time. Okay, lastly over here, here's one for you to try. I'm going to put the answer at the bottom in a second, but pause the video, try this one out, see if you can get the answer. All right, here is the work. There's no greatest common factor. If you followed our steps, you should have ended up with x plus 5 times 2x minus 1, or the other order, which I wrote at the bottom of the screen, 2x minus 1 times x plus 5.